Hello, everybody. My name is Vladan Jevremovic, and I will talk about the prediction accuracy report. Prediction accuracy report is the report that compares predicted and measured data in iBwave design. The difference between the two is called prediction error. Prediction error statistics are mean error, absolute mean error, and standard deviation. The predicted signal is the median. Measured signal has a 50% chance of being higher than and a 50% chance of being lower than the predicted signal. Prediction error should have a random distribution around the mean prediction value. Ideally, the mean error should be equal to or at least very close to 0 dB. In practice, the mean error is often not close to 0 dB, but is always a bit lower than absolute mean error. So how does a good report look like? What do we expect to see? Mean error should be a few dBs less than absolute mean error. Absolute mean error should be less than 6 dB most of the time, rarely between 6 and 7 dB, and never above 7 dB. Standard deviation is the same. It should be less than 6 dB most of the time, rarely between 6 to 7 dB, and never greater than 7 dB. So here are the examples. This is an example of a good report. We see that the mean error and absolute mean error are not the same. They're about a dB apart. And standard deviation is a bit less than 6 dB. The next one, we see that values are a little bit higher, but still mean error is about a dB and a half less than absolute mean error. And standard deviation is still less than 6 dB. So now that we have seen how a good report looks like, let's take a look how a bad report looks like. A bad report is such that absolute mean error and mean error are almost the same. The measured data is either always smaller than the predicted data, in that case, mean error has a negative sign, or the measured data is always larger than the predicted data. And in that case, mean error has a positive sign. And this is an example of a bad report. You see that the mean error and absolute mean error are only a few tenths of a dB apart, and themselves they're rather large. What could be a possible cause? A possible cause could be a mismatched transmit power or antenna gain, or both. So action items in this case would be to measure the received signal and compare it with the free space path loss to get the most recent antenna spec sheet from the manufacturer and to verify that correct antenna model has been used in iBwave design. So the first example of a bad report is a power mismatch. Second example has to do with walls and locations of the transmitter. And you will see that the standard deviation is much larger than expected. This is the case. It is much larger than 6 dB. So one possibility is there is a missing wall, or simply they're incorrectly labeled walls. Such as that you thought that wall was of one material, turns out to be of another material, or a wall is missing, or a wall is modeled where it shouldn't be, etc., etc. But we're just focusing on a case of a missing wall. Here you see the survey data, and you see how it drops from bright red to green over a very short distance. And this sudden drop in measured signal indicates that there is an obstacle between those two paths. And this is the survey data showing us where the missing wall is. So obviously there was a wall that was not modeled there. And that is something that needs to be changed. So first lesson, always look into your survey data very carefully and see if it tells you that there should be an obstacle somewhere in there. The second example is inaccurate transmitter location. And here we see two examples. In one example, there is incorrect antenna position, and Another one is correct antenna position. So how do we know that? Well, survey signal should have the maximum value underneath the antenna. And if it is not, then you need to move your antenna in a correct position. So action items here is to take extensive on-site pictures and videos, to compare existing on-site floor plan with what is in the iBwave project file, measure wall penetration loss, and compare pictures with the transmitter with location on the floor plan. So this is all for today, and I hope you enjoyed this video and have a good day.